Okay. So in circular linked list, in normal linked list, the last node will have a null in the next field, whereas in case of circular linked list, we are going to replace that null with the address of the previous node. So here we have two types of circular linked list. One is circular single linked list and another is circular doubly linked list. Today we will focus the circular linked list, single linked list, which is the extension of single linked list. Let us see first what is circular single linked list. So in case of the single linked list, when the last node is connected to the first node, then we will say that it is a circular single linked list. So here, if you see the head pointer, here also the head pointer will contain the address of the first node in the linked list. And when we go for the circular single linked list, we have certain advantage over normal single linked list. The advantage is nothing but you can access any node from any other node. For example, in linked list, you cannot access the first node from the last node. It is not possible because after the first node, you will have after the last node, you will have the null pointer. You will not know again how to come back to the beginning. But in case of circular linked list, that disadvantage is overcome. So you can access any node from any other node. So now let us see the diagram representation for this. So in this first, we have three nodes in circular linked list. If you see the address of the last node, in case of the last node, see the link field. Here we don't have null. Instead, in the link field, we have stored the starting address of the first node. So the first node is stored at the address 1000. So that 1000 is available here. So what is the meaning of this one is, this is containing a pointer to the first node. So we are forming a cycle. If you see the diagram, there is a cycle. You can start from any node. You can access all the remaining nodes. For example, I am starting from node 2. In case of single linked list, you cannot access node 1 from node 2 because you have only pointer in one direction. But if you have a circular linked list, I am starting from node 2. If I want to access node 1, first I will go to node 3, then through node 3, I will come back here to node 1. So I can access any node from any place. And the address of the first node, which is 1000, is stored in the head pointer. Now, here we have primitive operations as the normal linked list. So we have create, then insertion, deletion, and then display. In insertion and deletion, we have three different operations, either at the beginning, or in the middle, or at the end. So for the remaining cases, we have only one case. Now let us focus on all these operations one by one. First, let us see how to create the data structure for this. So the data structure of the circular single linked list is similar to single linked list only. So every node will contain two fields. One is the data field, another is a pointer to the next node. Here also we have pointer only to the next node, not to the previous node. Okay, so these things are used for the program. We will come to this later, just variable declarations. Now, first we'll focus on the create function. In case of the create function, we can use this function to create only the first node in the linked list. And if you want to create all the remaining nodes, you have to use only the insert function. So let us see how this create function works. First, let us see the empty list. First, we have the empty list. Empty list means your list is not having any data, but you will have the head pointer still. This head pointer will have the value null. Since it is null, it means that it is not pointing to any list, so it is empty. Right. So now let us see how to create your circular single linked list. So create means first we are going to create only one node. So if you want to create one node, definitely head pointer should be null. If head is equal to null, it means that the list is empty initially. So you are going to create the first node in that. So when you want to create, the first step is you need to allocate the memory by means of the malloc function. So after malloc is over, you get the value of the data from the user and store it in the memory. After that, now this line is very, very important. Whichever is unique to this, I will focus on that. Whichever is already seen by you people, I'm not insisting more. So you focus on this line. A new of the next of new is new. What is the meaning of this? You can see this one. This is a circular linked list. How many nodes we have in this circular linked list? Only one node. So if you see, in case of circular linked list, the pointer of this node is again pointing to the same thing. That means that there is a cycle. Okay, so you have, even if there is one node, you have to update this field properly. the address field. It contains the address of the next node actually, but in this there is no next node. So you should not store null because it is a circular linked list. You have to again store the address of the same node here also. So how to do that? The next of new, that is new arrow next, is stored with the same new. New is now 2000. In the next field of the 2000, you store 2000 itself. So when you do this, the cycle will be created. After that, since you have created a node with linked list with one node, you have to store the address of this in the head pointer. So I am writing head is equal to new. Okay, so this line is special in circular linked list. Remaining are same, similar to single linked list only. Now this is called create. Now let us see the full create function. Inside the create, first you are checking whether head is equal to null. If so, you allocate the memory. After allocating the memory, get the data. Through new, you access the memory and store the data in that. After that, you have to do 2 pointer changes. One change is you have to make the node to point to itself because it is only one node present in it. So I am writing new arrow next is equal to new. Then you write the address of this newly created node in the head pointer so that head will point to the first node. So I am writing head is equal to new. Else, what is the meaning of else? Else means when head is not is equal to null, it will come to the else part. That means your linked list is already existing. Actually, I told that create is only for creating the first node. If it is already existing, you are not going to create it. So you write that the linked list is already existing to the user. So this is for create function. Now let us focus on the insert function. Insert function is more or less many functions will be similar to single linked list only with few changes will be there. So what is insert? In insert again we have insert in 3 cases. First we will focus on insert at the beginning. So in insert at the beginning, so my circular linked list already contains 3 nodes. Okay, I'm going to insert a new node to this. Right. So as usual, first we will create the memory for the new node. Then we will store the data in the new node, right? So these steps you already know. Let us focus on the new thing. In case of this insert, what are you going to do? First, you can see here, this linked list is going like this. When you see the last node contains 1000. 1000 is nothing but address of the first node, okay? And when you insert this node in the beginning, the address of this node 500 should be stored here. Instead of 1000, you should have 500 in this node. Okay, so now we are going to do those things. So first what we are going to do is we are going to keep the copy of head in new arrow next. So what is the meaning of this? See, previously your head is pointing to this node. So the address of this node is stored in head. But now since you are going to insert this node in the beginning, only the new node will be pointing to this particular node. Instead of head, only the new node will be pointing to this node. So what I'm doing is, here I have to store this 1000. The 1000 is available in head. So I'm copying the data from head. I'm storing it in new arrow next. When this is done, this arrow will be created. Okay. So now both head as well as this will point to this node. Okay. Then what I'm doing is, I am keeping a copy of the data available in head in temp. That means I am creating this one. Why I need to create? Because I have to travel through the entire linked list. I have to find this part. Okay. Whenever I want to travel through the entire list, I have to keep a temporary variable. So in temp, I am copying the value of head. After that, I am checking whether temp of next of temp is not is equal to head. Generally, you want to find out which is the last node. There we will write temp arrow next not is equal to null. But here, in case of circular linked list, we don't have null. Instead, we have the same value as that of the head. Okay, so this contains the head value only. That is a circular linked list. Head means the address of the first node. The address of the first node is stored in the last node. Okay, so what you are doing is you are checking whether the next field of temp is not is equal to head. If so, you have not reached the last node. Our aim is we have to reach the last node. Okay, if next of temp is not is equal to head, we have not reached the last node. So what you will do to reach the last node, every time you need to update this temp. Now temp is nothing but next of temp. That is, previously temp is 1000. Now I will take this 1500. I have to store it in temp. Then I will go to this 1500. I will check the next field. It is 1600, which is not is equal to head. Okay, it must be equal to head. Then only you will say that it is the last node. Now this 1600 is not is equal to head. So again, I will take this 1600, store it in temp. Then I will go to 1600. I will check the next value. Here next value is 1000. 1000 means it is head, same as head. So when temp of next is equal to head, I will come outside. Now, let us see. When I come outside, what is my temp value? Temp is 1600. Why? Because in 1600 only, in the next field, I have 1000, which is the address of the first node. So when I come outside this loop, my temp will be having a value as 1600. Now these lines are over. Next, what I have to do? Still, my diagram is like this only. Okay, there are certain changes I have to do. Now, when I come outside, what I will be doing is, see this arrow. Previously, this was pointing to this node, 1000. Okay, now instead of 1000, here I have to change 500. When I change 500, what is the meaning is, this node is pointing to the new node. Okay, so how to take this 500? Where this 500 is available? This 500 is available in new. Okay, that you have to store in this particular place. Okay, so what is this place? How to access this place? My temp is now 1600. Okay, in the 1600 address, in the next field, I have this data. I have to store this data. That means in next of temp, I have to store the value of new. When I store this one, after this line is executed, the link of this node will be pointing to the new node. Now, so if you see now, my head is still pointing to the previous first node only. Okay, it is pointing to the 1000 address only. But now this is a first node. The newly added node is the first node. I have to store the address of this node in the head pointer. So now I have to make head to point to this particular node that is pending. So let us see the next step. So the next step is nothing but take new and store it in head. If you do that, this line will be created. So it means you have created the entire linked list. This one you have added in the first. So head is pointing to this node. And then you made this node to point to the previous first node. Then you have made the previous last node to point to the newly added node. So 3 changes we have done. Okay. So now this is an entire insert at beginning function. So whatever steps we have seen so far, I have written everything in the order I have explained one by one. So now let us see how to insert at the end of the linked list. So now this is my linked list. Here I want to insert the new node, that is this node 1 at the end. Okay. So now let us see what all the pointer changes I have to do. So here this step is always insert means you create the node and you add the data in that. So this is there for all the inserts. Right. So now let us see what are the special things in this. So first, whenever you want to insert this node at the end, you are going to insert at the end. So you have to travel through the entire linked list and find out which is the end node. Okay. So whenever you want to travel through the entire linked list, keep the temporary variable and copy the head in the temporary variable. So I am writing temp is equal to head. Okay. And then I have to find the last node. How to find the last node? You have to check whether the next field of temp is not is equal to head. If it is not is equal to head, it is not the last node. If it is equal to head, it is the last node. Okay. So I am checking whether the next field of the temporary node is not is equal to head. If so, I have not reached the last node. So I have to make my travel to reach the last node. To make my travel easy, I am storing this one. Temp is equal to temp arrow next. Right. So now, when you come outside that loop, where you will be pointing is you will be reaching in the last node. You will be in the last node. Okay. So your temp will have a value of 1600, right? Because in that only the next field is the address of the first node. Okay. So now what you have to do when you come outside the loop, again, here you have to store the address of the new node because this new node will be added after this one. Okay. So now the new node address is available in the variable new that I am copying in next of temp. So when this line is executed, this arrow will be created. Previously, here you had 1000, which is address of the first node. Now I am removing this. I am storing the address of this node because 1 is inserted after 3. It is now the last node, right? So now what are the other steps we have to do? After that step is over, you have the diagram like this. Okay, so now in this, if you see here in the green node, in the next field, I don't have any data. Okay, now I have to insert the data in the next field of the green node. So what I have to insert in the next field of the green node? It is the last node now. So it will contain the address of the first node. So I have to take the address of the first node, that is 1000. I have to put it here. So how to do that? So for that, first we are going to, this one we have seen in the previous slide, so I'm not repeating it. So now here we are going to store 1000. This 1000 is available in head. So I'm going to take 1000, that is head, that will be stored in next of new. So when I do that, this link is created. Okay. So now, do you want to do any other changes? See here, already temp is, already my head is pointing to this node only. Still it is pointing to the same node, so no changes are required there. So your program is over, insert at end is over. So all the steps are written here. Okay. So next is insert in the middle. So here, whenever we talk about insert in the middle, we are not going to insert as the first node or not going to insert as the last node. We are going to insert in the middle somewhere after some value. For example, I will say that insert the new node after 2. 2 means this value. Or I will say insert node after 5. 5 means the data value, which is not existing now. Okay, so you have to insert a node after certain node. That means you will get this value from the user. This value you will get from the user. After which node you want to insert, that you get from the user. So first, I'm asking the user to enter the key. The user will be typing the key. Here key is nothing but this data field. Okay, after that I am creating the new node to be inserted. I'm allocating the memory for that. Then in that I am storing the data field. That is this one I am storing in the new node. Now, let us see what changes we have to do when we want to insert after a node. So here, let us assume that the user is typing the key as 2. What is the meaning of this is, after the node with value for data as 2, that is after this, I want to insert this new node. Okay, so you have to find the proper position of the node. That means you have to travel through the linked list. So you keep temporary variable and copy the value of head in the temporary variable. So I am writing temp is equal to head. So after this is over, I have this created. After that, I want to travel through the entire linked list and find where I want to insert. So I have to check. See, previously we have checked temp arrow next not is equal to head. But here you are not going to check that one. You want to check whether you have reached a node whose value is equal to key. Okay, so I'm going to write while temp arrow data not is equal to key. It means that I have not reached the node after which I want to insert my node. So I have to travel further. So I am writing temp is equal to temp arrow next. When you come outside the loop, what is going to happen is your temp will contain the node address in which you have the data as key. That is, according to this diagram, when you come outside the loop, your temp will have 1500 because in 1500 only the data value is equal to key, right? So now, when you come outside the loop, this is your diagram. Temp contains 1500. Now, what you have to do? After this node, that is after this 1500, after this blue color node, you have to insert this green color node. So now let us see the steps. So when you come out, you have to insert this green color node after this blue node. Okay, so that means you have to make this new node to point to this data now, because previously 3 is pointed by 2. But now you are going to insert this new node after 2. That means this new node will be pointing to 3. So store the address of 3 here. So the address of the 3 is 1600. It is available here. Okay, that is nothing but your temp is 1500. In the next field of temp, you have the address 1600. That address, you have to store it in the next field of new. Okay, so I am writing new arrow next is equal to temp arrow next. When I do that, this green color line will be created. Now, what is still pending for you? You have to insert this node after 2. That means this arrow from 2 should point to this node. It is still pending. So you have to do that. So what I'm going to do is I'm going to store the address of the new node, that is 500 here. So I am writing temp arrow next is equal to new. When I do that, this will happen. I will be storing 500 in this node. That means this node will be pointing to this. Now, if you see the movement, from 1, you have 1500, so you will come here. From 1500, you will get 500, you will go to this new node. Then from 500, you will get 1600, you will go to this node. Okay, so that means we have inserted the new node after 2. That is after the key value, whatever the user has typed. So the step is over. So all the steps are written in the form of a function. Now let us see delete. So far we have seen all the 3 insert. Let us focus on the delete function. In delete also we have 3 cases. First we will see delete at the beginning. So in case of delete at the beginning, so your linked list is like this. Remember, this is a circular list. So the last node contains the address of the first node. And the address of the first node is also available in head. I want to delete the first node. When I want to delete the first node, what are the changes I have to do? Remember, first you have to do 2 changes. One change is make the head to point to the second node. And the second change is the last node is now containing the address of the first node. This you are going to delete. So in the last node, you have to store the address of the second node, not the first node. So these 2 changes you have to do. After doing those 2 changes, you will be releasing the memory of this node. So now let us focus on the steps. So now I have to change the address of the last node. So I have to travel through the entire linked list and find out the last node. So for that, I am copying the value of head and temp. Okay, I need to find out the last node. So the last node is found by using this. You have to check whether the next field of temp is not is equal to head. If it is true, you have not reached the last node. So further travel through the entire linked list so that you reach the last node. So for that, I am changing temp is equal to temp arrow next. Remember these steps, students, it is only for moving from one node to another node until you find the node of your interest. Okay. So when I come outside this loop, I will be in the last node. That is, my temp will contain the address 1600. Right. So now I am at this node. So what I have to do here, I have to store 1500. That is address of the second node because this node I am going to delete. So 1500 is available in this field. Okay, so I have to take this, I have to store it here. Okay, and one more thing, after doing this, I will be deleting this one. So to do the deletion, we need to use the function free. For free, we have to give the starting address of that block. So I am copying the starting address of this block in another temporary variable. So in pointer variable PTR, I am copying the address of this block. Okay, the starting address of this block is available in head. So I am storing the value of head in PTR. When I do that, I will be copying the address of this node in PTR. Still, this is pending. Okay, this arrow is still pending. This I am going to do now. So how to do this arrow? So what I'm doing here, I am storing this address. That is, I am storing this address 1500 in this place. Okay, so how to do that? How to get this 1500? It is nothing but it is the next field of head. Head is containing 1000. So in 1000, in the next field, you have 1500. So this you have to take and you have to store it here. Okay, so how to access this one? This is nothing but next field of 1600. 1600 is available in temp. So it is nothing but next of temp. So I am writing the statement head of next of head is stored in next of temp. When I do that, this arrow will be created. If you see this diagram, 2 things are still pending. One is you have to make this head to point to this node, and the another is you have to release this memory. Now let us see them. I have to do this proper pointer change. So for that, I am copying the head value in the PTR. This one is already over. It's on the 3rd step. That is the last step. This only we are going to do now. Okay, so this we are going to do. So what I'm doing here is I am taking the value of next field of head and I am storing in head. So previously head was pointing to this. The next field of head is 1500. I have to store it in the head variable. So I am writing head is equal to next of head. Okay, after that I have to release this memory. So I am writing free PTR. So when this is over, the pointer will be released to the free garbage area. Now head is pointing to the second node because you have deleted this. So this is beginning. So the whatever steps I have explained, the same thing is written here. Next, delete at end. So in delete at end, we are going to delete the last node of our linked list. So here I want to delete the node 3. Okay, when I want to delete this node, again, I have to travel through the entire linked list. I have to find out which is the last node. So for that, I am starting with head. I am storing head in a temporary variable. Then I am writing the loop. In this loop, here this is slightly different. Delete at end is slightly different. You will have two statements inside the loop. Okay, so now in this loop, what we are doing is we have to track the last node. So to track the last node, you should write the next of temp is not is equal to head. This is a condition for tracking the last node. Okay, so when you reach the last node, you have to do some changes. And before that, we have to do two things. One is whatever is the current temporary node that we are storing as a previous node. Okay, and then we are taking the next of the temp node and keeping it in the temp variable. Let me explain here. First, when you start your head, your temp will be pointing to this particular node. Okay, because you are writing temp is equal to head. Temp will be pointing to the first node. Then you are taking the next field of temp. It is not is equal to head. So you will make this node as previous and then this node as temp. Okay, every time you are going to make the current temp as previous and the next of temp as temp. That is, after first iteration is over, the node with 1 will be previous and node with 2 will be temp. Then in this node, I will check the link field. Link is 1600, which is not is equal to head. So what I will do, I will make this particular node blue color 2 as previous and then green 3 as temp. Then I will check the head of link of this node. The next field of this node is 1000, which is equal to head. So at this point of time, I will come out. When I come out at this point of time, my temp is nothing but this node and previous is this node. Okay. So temp will contain the address 1600 and previous will contain the address 1500. Okay. So when you come outside this loop, you are keeping track of two things. What is the current temporary node and what is the previous node of that? Okay. Because you want to delete at the end. So here some special changes are involved. So we are keeping track of the previous node also. So we are coming outside this loop and this will be the data at the end of the loop. Let us go to the next slide. So when you come out, your node 3 is pointing to this and node 2 is pointing to node 3. Okay, now we are going to do some changes. The first change is we are going to make node 2 to point to node 1 because 3 we are going to delete. So how to do that? In node 2, in the link field, we have to store 1000. Okay, so this 1000 is available here. It is available in the next field of temp. Okay, so I have to take the next field of temp, then I have to store it in the next field of previous. You see, I need the address of this node. For that only, I have stored the address in the variable previous. Okay, so take the next field of temp, which is nothing but this 1000, and store it in the next field of previous. That is nothing but here. After that, this diagram is created. Now, what is pending step? You have to release this to the free storage. So I am writing free of temp because I need to give the starting address of this block. It is available in the variable temp. So I am writing free of temp. So when this is over, you will have the memory released to the garbage area. So now this is the entire step for delete at the end. Now, let us focus on delete at the middle. So in delete at the middle, you are going to delete a node whose value is entered by the user. Okay, middle means you don't know what data you want to delete. There may be so many middle values. So you will say that I want to delete the node whose value is equal to 2. This 2 you will give from the keyboard. Okay, so you read the value of the key. So for that, I am asking the user to enter the key and I am storing it in a variable called the key. According to this diagram, I want to delete where key is equal to 2. Then, now I have to travel through the entire linked list. I have to find the node. Here, what is the condition? Whenever you want to travel through the entire linked list, you keep head value in a temporary variable and start your search. Okay, so now what is my condition here? Check at the condition. You are now going to check the data. You are not going to check the pointer. You are going to check the data. So I am writing temp arrow data is not is equal to key, because when it is not is equal to key, I have to continue. If it is key, I can come outside the loop. Okay, so here, if temp arrow data is not is equal to key, you have to continue. What you have to do? You have to make track of two things, keep track of two things. One is whatever is the current temp node, you have to make it as a previous node, like whatever seen in the previous step. Then you have to make the next field of temp as a current temporary node. Okay, so first, according to this diagram, when I start, previous will be equal to 1000. Okay, and temp will contain 1500. Okay, so whenever I come outside the loop, temp will be 1500, because that is having the value as 2, and the previous will contain this address 1000. Okay, right. Now what we have to do when I come outside the loop? So here, when you come outside the loop, you want to delete this green color node. Okay. So when you want to delete this green color node, you have to do one pointer change. The pointer change is nothing but, if you delete this node, you have to store 1600 instead of this 1500. Right. Now, where is this 1600 available? It is here. Okay. So it is nothing but it is in the next field of temp. You take it and store it here. This can be accessed by the next field of previous. When you do that, this address you will take and you will store here. The meaning is this is now pointing to 1600. So you can remove this green node. So I am writing now free of temp, because temp contains 1500, which is the starting address of this block. So you write free of temp. So when you run all these steps, the node will be deleted. Now you can see we are not at all touching the head pointer, because it is still pointing to the first node. Okay, right. So now all the delete functions are over. Let us focus on the display function. In case of display, it is very simple. Display is very simple. You are going to start with the first node, travel through the entire linked list one by one, display every node, then you go to the next node. So for that, whenever I want to travel through the entire linked list, I have to keep a temporary variable. I have to copy head value in that. So I am writing the display now. First, I am going to check whether head is equal to null. It means that my list is empty, no value in the list to be displayed. So I am printing a message to the user and then I am returning to the main function. Otherwise, I have some data in the list, so I have to display the data. So for that, I am going to copy the value of head in a temporary variable. Then I want to display all the nodes one by one. So I need the condition to check whether I reach the end of the linked list. So for that only we have this condition. If the next field of temp is not is equal to head, it means you have not reached the end. If it is equal to head, you have reached the end. Okay. So now, if the next field of temp is not is equal to head, it means that I have not reached the end. So I have to display the data of that particular node. So I am displaying. After that, I have to go to the next node. To go to the next node, I am writing temp is equal to temp arrow next. Now, when I come outside the loop, I have written one more print statement here. Why that statement is required? You can see this diagram. When I come outside the loop, I will have this node. When I come outside the loop, the next field of temp will be equal to head. That means you can see this is temp. Okay, temp is 1600. Next field of 1600 is 1000, which is head. So when you are pointing to this particular node, you will come outside. You will not display this 3. So now you have to display that also, because it is pending, still pending. So you write the step for that. So I am displaying the data of the temporary node, because I have not displayed it in the while loop. At that point of time, I came outside the loop. So I have to write the statement for displaying that node also. So with this, display function is over. I have not written the main function. It is same as the previous functions only. It is just